Chapter 2, still talking about tools that scientists use to answer questions. And today's section, 2.2, is focusing on measuring time and temperature. Especially at the lower grade levels here, we do a lot with time and temperature. So it's really important that you kind of have a full grasp of how we use those tools and measure them in science. So 2.2, measuring time and temperature. So often it's important to measure time in experiments, and we are very familiar with time because we use it a lot in our lives. We know that we use things like seconds, hours, minutes, days, and years, and we adjust those units depending upon what we are measuring. For example, if you're trying to figure out how long it takes someone to eat their lunch, like the boy in the picture, you're probably not going to use years. You're probably going to use something like minutes, right? If I'm measuring how long it takes someone to run the 100-yard dash, I'm probably going to use seconds and I'm not going to use years. So I want to make sure to adjust those units based on what we are measuring. So how do each of these units relate to each other? So we should know these relationships with each other. There's 60 seconds in a minute, 60 minutes an hour, and going on there. But those are kind of things that we should have memorized because sometimes we are asked, even though we measure a time in a certain unit, sometimes we're asked, what is that in hours? What is that in days? So sometimes those can change. So how many seconds are in 1 hour? 6. We're going to take 60 seconds in a minute, 60 minutes an hour. So 60 times 60, right? To get how many seconds are in 1 hour. How many seconds are in 30 minutes? If there's 60 seconds in 1 minute, take 60 times 30, and then you're going to get how many minutes are in there. So it's just a relationship between those two things. So it takes about 156 days to grow a pumpkin from a seed. So you could figure out then how many months does that take. Sometimes I know that happens a lot when, kids are younger. People will use sort of like weird terminologies. They're 10 months old or they're 24 months old, and you think, why don't they just say 2 years? Sometimes we just do those things, and definitely if you're a gardener, this is what they use. They'll use days here, so you could actually kind of figure out how many months that is, right? Because we know on average how many days are in a month. Temperature. So what temperature is, we are very familiar with temperature, especially living in Minnesota because we have such fluctuations in temperatures. Temperature is a measure of how hot or how cold something is. Really what you're actually doing is measuring how fast molecules are moving. So the faster the molecules are moving, the hotter that substance is. The slower those molecules are moving, the cooler it is. So when we heat things up, so think about if you're going to make pasta and you're making it on the stove. You put water in there, you're going to add some heat to it. What you are doing when you are adding that heat to it is you are making those molecules move faster. When you are going to make ice cubes and you take water and you put it in the ice cube tray and you put it in the freezer, you are taking those molecules and you are slowing them down. You're actually taking energy out of them when you are making ice cubes. So that's what temperature is. It's the speed of molecules in a substance. The hotter something is, the faster its molecules are moving. The cooler something is, the slower its molecules are moving. And this is a really important concept. There are so many things in earth science that are determined by this. We're going to talk about density when we talk about how air moves or when we talk about ocean currents. It's all dependent upon this very basic principle. So hot things, molecules are faster. Cooler things, molecules are moving slower. Now, scientists commonly use Celsius for temperature. That's the most common measurement. Remember, the United States, we're one of the only ones hanging on still to Fahrenheit. You go anywhere else, it is going to be Celsius. However, in the metric system, which we're recently learning about here, the metric system standard unit is not Celsius. It's actually a unit called the Kelvin. So the SI, remember that's the shorthand version for metric. The SI unit for temperature is actually Kelvin with capital letter K. And it's not given in degrees, it's given capital letter K. Kelvin's importance, one of the important places on the Kelvin scale is what we call absolute zero or 0 Kelvin, and that would be the point at which essentially molecules are not moving anymore. Remember, we just said when you cool things down, those molecules slow down. So eventually couldn't you think you could get to the point infinitely where those molecules stop moving? And that would be absolute zero. And I do not believe we as human beings have obtained that temperature yet. So just to compare these two that we're familiar with, so we're familiar with the one on the left there. We know our thermostat at home, we're going to set it to about 68 degrees. If you're anywhere else that's using Celsius, we go to our neighbors of the North Canada, 20 degrees. Kind of weird for us to think, right? As soon as I say 20 degrees, you're thinking that's cold outside, right? Like, for example, this morning, it was 23 degrees outside. That's cold for us. That's below freezing. But if I'm in Canada and say 23 degrees Celsius, that's not that cold, right? That's room temperature. So 32 degrees Fahrenheit, water freezes. 212 degrees, it boils Fahrenheit. Weird numbers for us to remember. Look at the numbers on the right-hand side. Celsius is much easier. Water freezes at 0 degrees Celsius, it boils at 100 degrees Celsius, and then comfortable room temp around 20. If you're going to go take your temperature at the doctor, it's around 37 degrees Celsius for average temperature. Now, we used to go through these things in class. We used to actually do the math, and you can use these still if you need to. But now with our technology, it's just obviously so much easier to do that conversion back and forth with each other. We have different types of thermometers that we can use. We actually most often use these in science class now. So they're an alcohol-based thermometer. So inside of it, there's actually alcohol with a little bit of red dye in there. We use these because we used to use mercury thermometers, which were very accurate. However, they are very toxic. Mercury is toxic to the environment. It's toxic to animals. So it's our way of taking something out that doesn't become toxic in the environment. So when you have this substance inside of a thermometer, think about what we just said earlier. If I put that in something and those molecules are moving fast, that energy is going to be transferred to that alcohol in the thermometer. It's going to make them move faster, and then it's going to move up the tube of the thermometer. So all that's doing is it's an energy transfer. That's what a thermometer is essentially reading, is that energy transfer. We also have digital thermometers. We don't use them a lot in science class here. They're more expensive, but they're really nice and easy. You may have them at home to take your temperature with. Really cool. You just put it there. It's going to measure really fast what it is. Maybe you have an aquarium at home as well. We also have thermometers that work off of like a color change for you. Same thing. It's going to show you the nice temperature right there. So we do have different types of thermometers. When we start talking more about tools, we're going to learn the importance of being accurate. We want to be accurate when we report measurements, whether it's reading a ruler, whether it's reading a thermometer. So accurate measurements are factual. And we've been doing a little bit of measuring with our scientific method CUPS lab with the thermometers, and stressing the importance of being accurate when you're measuring, going to the tenths place and not just saying 1 degree Celsius, 1.1 degrees Celsius, 1.3 degrees Celsius. There is a difference between those measurements. So we need tools to be accurate when we're measuring them. So not only do I need to read it accurately as a person, that tool needs to be accurate. That thermometer needs to be accurate. So accurate measurements are factual. Another term we can use is something called precision. Precise measurements are close to the same value. It's your goal that when you are using a tool in science, you want them to be both accurate and precise. So I'll say that again. When we are using tools in science, we want them to be accurate and precise. We need them to be both things in order to trust their results. So accurate measurements are factual, precise measurements are close to the same value. And there's no better analogy than looking at a target, because most of us are familiar with this. We know that when we're using a target, whether it's we're doing axe throwing, whether we're playing darts, or whether we are, sighting our rifle in for deer hunting. A lot of us may do that up here. We want to get near the middle of the target. So that's our goal location. So if you are near the middle, you are high in accuracy. So you'll notice the two pictures on the bottom there. I'm near the middle, high accuracy. What you also want to make sure you're doing is your shots are all near in the same spot, right? Same thing with darts, want to be in the same spot. If they're all near the same spot, then we say it has high precision, right? Close to the same value. So you can see the two targets on the right-hand side, both of them are very close to each other, so they're high precision. The one we want to be at in science is the one on the lower right-hand side. This is where we want to be. High accuracy, high precision. Those two things mean I can trust those results. If you're sighting your rifle in and you're in the target on the top there, you know you have to make a few adjustments. You have high precision, so you got to make a little bit of adjustment so you can get that shot where you need it to be. All right, so now we need to go in and you guys are going to take the quiz on 2.2 in Schoology.